let's get into the basic testers and different types. The most common that an electrician will use is just known as a volt ohm meter. It will do resistance, AC, DC, things of that nature. Most common out there. A little continuity tester of different sorts. The one thing this won't do is test voltage of any type. It's just for testing switches and outlets out of circuits. It just lights up very simply. Okay.
But that one does it? Does it test the voltage test?
Yeah, this will do the same thing. Yeah. But here we can see if we want to just test a switch out of the circuit, okay, all I have to do is hook it to one of the screws, turn the switch on. It's a good switch. Okay, so very simple to use, has its purposes. The same thing if you're testing a fuse out of the circuit. It's a good fuse.
So the red light indicates that it's in working order.
Right, correct. So we know that's a good fuse also. You can test an outlet, actually, a light bulb out of the circuit if you want to. A light bulb socket, that is, okay.
Does it matter what pole you put the clip on, whether it's negative or positive?
Hot or neutral. Right now I'm testing the neutral.
Oh,
okay. Here's, I'm at the center contact, no contact because I'm on the neutral wires, which are the threads. Okay. If I want to test the hot, again, center contact. So this is a good light bulb socket. So continuity tester does have, you know, it's good uses. Very simple to carry around with you, but it will not test voltage. If I tried to test voltage with this, it would melt.
What is it testing then? If it's not plugged in, what exactly is it testing?
A good circuit. Actually, like from end of wire, you know, a piece of wire. It's just good. So that's all it's testing. All right. Again, with a volt ohm meter, and it's going to be hard to see, but we put it down into the ohm scale, measuring resistance, all right, and in order to test the meter, right now you can see a 1 on it probably. If I do this, I get a reading, which means, you know, I'm getting a good reading, and then back to 1. So that's doing the same thing as the continuity tester is, except it's measuring resistance.
Measuring resistance against what? Resistance. Can you lower against resistance?
Sure. Every piece of wire is going to have some resistance in it. Resistance to the electricity flowing through it. Okay, just...
So it's showing energy flow?
No, it's measuring resistance to electric. Okay, every piece of a wire is going to have some sort of resistance reading, some ohm reading in it. A light bulb will have a reading, even if it's good, okay? This just happens to be showing 0.5 ohm. That's in the wire just right here, okay?
So ohm is synonymous with resistance.
Right.
Huh?
All right. All the different basic tools and basic testers. Here's a little what we call a wiggy, but this one will also do the continuity test. It has its battery in it also, so this will do voltage and continuity. I just need continuity. You can see the little light because there's batteries in it, it supplies its own power. So this can test voltage in the circuit, or it can test continuity when you pull stuff out of the circuit. This is what's known as a tracker. I'll show you how they function in a little bit, but this is for energized circuits. This can plug in to an outlet, and then when I turn this on, you'll be able to find out which breaker is controlling that outlet. Okay, and there's a couple adapters you can go with it. If you're testing a light fixture and you want to know what breaker does the light fixture, that'll screw into where a light bulb screws into. And then you can plug that into here. If you're testing bare wires, you have an adapter, and you just put this into the adapter, and you plug that into here. And hanging from bare wires, you'll be able to then track those energized wires. This is for circuits that are hot now. For circuits that are cold or low voltage wiring, if you're testing doorbell wiring, intercom wiring, telephone, there are certain things like low voltage testers that can track wiring, but this is not for an energized circuit of any means. Okay, even low voltage, you don't want to test energized. You want to make sure that the wires are dead.
Meaning turned off at the circuit breaker?
Yeah, or the transformer in cases of low voltage. All right, the only one we really haven't gotten to is what's known as a clamp meter. This does a number of things, mainly for pros. The one thing we haven't mentioned is amperes, the power behind the voltage. This clamp will tell you how much power you have, not how much voltage, but how much power. It'll also do continuity and voltage, but once this clamps around a wire, it'll tell you how much power is being used in that circuit. That's all. And being used at that time, it can't measure potential power, like your house may have a 100 amp breaker, but it'll test, let's say your refrigerator is using 10 amps of power, that'll tell you if it's using 10 amps of power or not, what's being used at that time. All right, how do we use some of these things? Let's turn our house on. All right. Get one of the simple non-contact, which we haven't mentioned yet. Easy way to use the non-contact. Okay, it's just telling you that this outlet is hot. It's a non-contact tester. I don't have to clamp anything to a bare wire. It just has to get within proximity of the power, okay? And that's the neutral side. This is the hot side of the outlet. So it'll even say, you know, am I wired correctly? All right, same thing with a GFI. It'll tell you which side is hot and which side isn't. And there's a couple different brands, but they basically do the same thing. This one has a selective sensitivity, so it's sometimes, you know, you can get a hot reading through the neutral just because you're close to the hot, and this will bring the sensitivity down to help alleviate that.
When you're saying hot, that means the electricity is running through it?
Yeah. Mm-hmm. Right. Yeah, it's an energized circuit. In this case, 120 volts is there. Some of these will test multiple voltages, 120, okay. You just take this, and you notice that this is two parts actually if I wanted continuity, but If I'm just testing outlets, I put the parts together, put it in the outlet, and it's hot. Okay, it's actually designed to test outlets just like this. So.
But can you see a light, or how do you know?
Yeah.
Oh, okay.
The light's on this side because it's the hot side, right? So you
Well, no, I hear I'm in the outlet proper.
the light up on this side.
Yeah. So it's lighting up and telling you that this outlet is in fact hot. But it'll test different voltages. If you have a heavy-duty air conditioner at 240 volts, then you can make sure you've got 240 volts for that air conditioner.
Any of these testers, you just put it in.
Except for the continuity tester, you can't test continuity. You can't test voltage with this. It's strictly a low continuity tester. All right. How do we track a circuit? Let's put this into our circuit. By the way, besides being a tracker, this has a couple different functions on it. It'll tell you by the lights if you're wired correctly in the outlet. And it has a button to pop a GFI. So you can test the GFI at the same time. Okay, right now, I've got 2 orange. That tells me that this is wired correctly. That's all. If I wanted to test the GFI, I just tested my GFI because this outlet is wired to the GFI.
What did you just do?
I just tested this GFI.
How did you do that?
Push that little button right here. It's what you use in your kitchen and bathrooms. The outlets with the buttons on them. So if I wanted to test that, just because this outlet is wired through the GFI, I can test the GFI from this outlet. I just press the button. That means my GFI is functioning properly. I just turned it, I created a short to ground, okay, through this tester by pushing the button. And the GFI is functioning properly, that's all. Now, how do we use a tracker to find which breaker this is being controlled by? Again, it's got a probe that you can run down your circuit breakers or fuses. Sometimes you have to take the cover off in order to use these. So be aware that sometimes the cover does have to come off to get a good reading. But we'll attempt here to see what we get. Turn it on. You can see the scale. Okay, I get some sort of reading there. But now you can see I am getting a live reading over here, really no reading. So I come over to this breaker and I can hear it. It's going to be a little hard for, here, see.
So power's going through the one on the left, but not the one on the right?
Well, power's going through both, but I've got that tracker in that circuit. So I'm identifying what breaker is running that circuit. You can turn it off. Oop. So I don't get a signal anymore. So that means I've turned off the proper breaker. Now I can open this up, work on it safely without getting shot, because I know that it is a safe circuit at that point. You can have split circuits. So my recommendation is test both. Okay. A lot of places that were built in the 60s and the 70s without ceiling lights had a split circuit so that they sort of switched by the front door and it would activate a table lamp or a pole lamp or a floor lamp of some sort. So you could actually have two power sources in one outlet. So I recommend always testing both to make sure that it's not a split circuit of any type. In this case it wasn't. And again, the same thing. Where this comes in handy, if I'm testing a light socket, all I do oh, that's not good. We'll just turn that off. Because I just unscrewed my light socket. We'll fix that real quick. So, again, you can see now we got multi-tip screwdrivers. They come in handy. Since we were going to work on these circuits anyway, it's a good thing that this happened.
And since you're opening up the box, you've turned off the power to the...
I turned it off,
yeah.
correct.
Okay.
Gaskets?
Ah, yeah. There we go. Now, let's try one more time. Okay, so we're getting extremely funny readings here through this light bulb socket. So we have a problem with this circuit already, okay, because I'm not getting anything flowing through, and I'm getting weird readings. So the dimmer appears to be malfunctioning in this case. All right.
Quick question on that tester where you talk with the box. Is there any distance that the limit of distance between the box and the plug where you're dealing with, that it can't go beyond that?
Oh, I'm sure there's a distance of a couple 100 feet or so, you know, but for any building you're in, it's probably going to be okay unless you're in a high rise with 40 stories and you're trying to test all the way through into the basement.
Okay, so if you're in the basement, you check the second floor.
Oh, yeah, yeah. No problem at all. Even in let's say a 47 unit courtyard building where the power's all the way in the back and you're up in the front on the third floor, it'll be fine. All right, so we know we have a problem with this lighting circuit. Let's just see what our problem may be to begin with. All right, so it's just a standard light bulb, okay? This is an incandescent bulb. The soft start feature is a function of the dimmer, by the way, not the bulb or the switch here. It's, you know, that is actually a function of this dimmer. And I can bring it off down. You can see that's, again, a function of the dimmer. And Okay, so again, it seems to be functioning somewhat with an incandescent. But now that should have gone on, and now it's not. All right, should have turned it on. So again, we're experiencing some sort of problem with the dimmer itself, even on a standard incandescent bulb. Now, if we get to LEDs, all right. In fact, we'll do this here first. We can test, okay. Again, this dimmer works fine with an incandescent bulb. This is a dual controller, by the way. Dimmer on one side, fan controller on the other. All right, it'll work for exhaust fans, it'll work for ceiling fans of different types. You can see I've got it running at a very low speed here, or very high. All right, now.
So before you go on, can you explain to me, how do you know which wire goes where? You have a black wire there and then you have a white wire.
Right.
How do you know which one?
Because one's black and one's white. That's how you know
Yes.
that all light bulb sockets have two wires. One will be black, the other will be white neutral.
But how do you know where to connect the wire?
That's where testers come in. You notice that my black is, in fact, connected to a black in this case. And my white is, in fact, connected to a white.
And that's always the case.
It should be. I won't say it's always the case because some people will use the wrong color wiring. That's why I recommend, in fact, one of our things on our website says, test all wires in the box as you're working on them, even the neutrals, because I have seen and I've been shocked by hot neutrals where somebody just used a white wire as a hot. They shouldn't, but they do. Or if you're going to do that, you mark it with tape, like a black tape, which will tell anybody that's working there that that white wire is no longer a neutral wire, but it has become a hot for whatever reason. All right, this is an LED bulb. Turn it on. Very bright LED. But you can see that there's a little bit of incompatibility with this dimmer where the incandescent bulb dimmed nicely through its whole range. This one is not. Okay, it's basically, I should be getting at least 3 different dimming levels on here, and it's not doing it. So there's an incompatibility between the newer LED and this older dimmer.
That's through the bulb, is that right?
That's due to the bulb,
And,
sure.
and is this compatible? I mean, when you have that plus the fan, can you use it with the fan or not?
Well, yeah, this side is controlling the fan. This is a motor controller.
Even though you have a dimming light?
This is the dimmer. They're 2 separate knobs.
Yes, but, oh.
This is for the light. This is for the motor. It's not one unit. It's actually 2 different controllers in here. One dimmer, one motor controller.
I'm asking that because I bought a light bulb and it says that it's not to use with a dimmer in the fan. And I'm like, I don't know.
Right, well, if it's telling you don't use it, don't use it. It's as simple as that. A lot of, most LEDs that we sell here are all dimmable, okay? But in order, if you're going to buy the newer LEDs, make sure it says dimmable on the package. Okay? In this case it does, but again, you can see some incompatibility with this particular dimmer. It's only, you know, giving me 2 brightnesses where it actually should be giving me 3 and then off. So this is a very older generation dimmer, new generation bulb. There's a little incompatibility there.
So if it were a newer dimmer switch, that actually would work with that bulb?
Yeah,
What you're saying?
right. You'll notice on a lot of the newer packaging, in fact, let me go get one real quick. This just happens to be one of the newer dimmers. You will notice that it has a picture of an LED. It has a picture of a CFL. CFL is the same as a dimmer. It must say dimmable on it in order for it to be dimmable. And then the standard incandescent. So this will run all, and a halogen is incandescent. So this will run all 3 types of bulbs. They tell you right on the package what it'll do. All right, you can see that the LED does not like this dimmer whatsoever, okay? Even when it's on, quote unquote, it's doing funny things. So this dimmer is obviously not compatible with LEDs itself also. Not only does it not want to shut off, it doesn't want to turn on properly. Okay, so we'll turn our house off for now. Going to take this dimmer out of the circuit.
Can you explain what each of the different colored wires are?
Sure. The reason I have 3 different colors attached to this dimmer, okay, is because this is a 3-way dimmer to begin with. It's hooked to this switch. All right. So what I've done when I wired it, obviously my black is my hot in this case, and my 2 travelers just happen to be, in this case, red and blue going to this switch.
Are those hot as well?
Only when, yes and no. If I turn this switch off and this one on, let's say this one will go hot. Okay, if this switch is on, I turn it off, but it'll do just the opposite. This one will go hot, this one will go cold. The hot is hot all the time. 3-way switch switches between what are known as the travelers, so the other switch can turn it on and off also. No matter which position they're in, one of those switches will be able to turn it on at any period of time.
So how do you use the tester in the box on those connections to make sure that they're got it shut off? It's not hot.
Good question. Well, I'll be able to tell you here in a second. In this case, I turned both my breakers off, so I know it's off. But, good question. Okay.
Now that box was the green to neutral.
No, white is neutral. Green, the color green should, again, always be ground. Just like some people will wire a white wire to a hot, same thing can be said for green. Okay, but universally green is always ground. So you can see my green wire running through here in a couple places. to the GFI, to the grounding strap of this transformer. All right, so yeah, I do have green wires in here running in a couple different places.
Ground, you're referring to what?
Ground. All this piping is grounded, okay? I just happen to have a secondary ground wire also. It's probably wired to the box up in here.
So that's not hot or cold? It's
Correct.
A third category.
A third category of ground, right. Earth, ground.
Okay.
Just like this whole system in your house or apartment building or condo is grounded. Okay, it's grounded to the earth as a matter of fact. All right, it's grounded obviously through here, you know, through my outlets to ground rods that are stuck in the ground. It's not a neutral, it's a ground. It's totally separate.
So grounding is preventing from getting shocked.
It's a safety, correct. Yeah. That's why it's all, okay, now how do I test to make sure this is in fact off? Well, here. What I would do, since ground is ground, okay, no light, right? Now if I turn the circuits back on, and I don't know which one it is at this point, okay, oh, I'm hot. All right. Not hot, not hot, hot. All right, so that in fact is my hot. I know that as a matter of fact. Turn one breaker off. Oh, that got it. That shut this circuit off. But just to be on the safe side, we'll take them both off.
And this might be a stupid question. If that wire was hot and like you grabbed the non-coated part, is that like when you get shocked?
No. What I would get shocked is if I was holding onto the box and then grabbed it. Because now I'm grounded. This way I can turn my circuits on. I'm touching a hot wire, but I'm not touching anything else. Plus I've got rubber shoes on. Okay? So you can in fact touch a hot wire. I don't recommend it, but you can in fact touch a hot wire. Yeah. Good.
But if you're trying to unscrew something and it's quote unquote hot, unless you have a rubber.
Right. You'll notice that most screwdrivers, are all metallic. Now there are some screwdrivers that are rated to 1,000 volts that are covered except for the very tip. Okay, they're all coated, so they are designed to protect against that kind of thing. All right, 120 volts I have seen cut a screwdriver in half. Okay, everybody says, oh, it's only 120 volt. I've seen 120 volt cut a screwdriver in half. All right, so it's not something to be messed with.
Sequence that's safer than what use the hot to black before white or white before black?
No.
Just to make sure that.
No, again, if you're opening up something like this, I tested all 3 wires, discovered that was the only real hot wire, just by the lighting. So I know that's my hot wire, where the other 2, because I wired this already, they're travelers going to this 3-way switch down here. All right, so new dimmer, my malfunctioning dimmer over there. All right, this one just happens to have two reds as opposed to a red and a blue, all right, and a black. Well, what does the black tell you right off the start without even me reading the instructions that came with it? That's where my hot goes. So we'll wire. And you notice, I'm not even using any tools right now.
What is that thing called? Is that a cap?
Wire nut. Wire connector, wire nut, doesn't matter.
Does that switch on?
The power is off. I've got both my breakers off. Actually, I could have wired that hot if I wanted to. I didn't want to, by the way, because that's not safe.
That's what I was asking, if there's, you know, if you did the one before the other and you're on, whether it's safe one way or the other way.
No, there's no specific sequence of wiring to test. The first thing you want to do is actually verify that your hot wire is in fact hot, so you can either cap it if you're working there or shut the power off. Okay, either way. All right, I put a new dimmer into the circuit. My hot's wired to the hot, the travelers are wired to the travelers. Let's see what happens with the newer LED and the newer dimmer. Okay, turn our power on, see what happens. Off, on. Okay, this dimmer will not bring it down all the way. A lot of LEDs are set that way because they can't dim all the way down. There's a certain threshold that the capacitors in them need to be fired up in order for them to run. So this one is probably going down to about 5%, whereas at this point an incandescent bulb would just go off. But I can turn it off because this has an on-off switch. All right, but again, and turn it back on. This will preset, so it'll automatically go to my preset. I can bring it down, and it'll go to that preset. And turn it off, turn it on, depending on which side of the house I'm coming in at. We know that this LED bulb is compatible with this dimmer, although it won't shut off completely through the dimmer itself. Okay, there's that low threshold on this one, so it has to be turned off at the turning it on. It'll be fine. So not only have we identified a bad dimmer, but we've tested for the hot wire in here. We've shut off our breaker. We've changed our dimmer, and it's a nice compatible dimmer now. And it's basically as simple as that.
Yeah, well, now we've got, so it didn't matter, hot to hot, that's fine. But the other wires didn't matter to follow the color code?
No. Travelers don't matter because, again, on three-way switching, the hot comes in one switch and the switch wire goes out the other switch. All right, three-way switching has what's known as a common. All right, you'll have one dark screw, or in this case, different color wiring. I had two reds and a black. A three-way switch will have a dark screw and then two normal brass screws. All right, the common. This is my common on the dimmer, okay, where my power is coming in. My switch wire is actually on this switch, the wire that goes to here, okay? This is my switch wire going out the common on the second three-way switch. You can see my switch wire is actually coming from down here, not from here. So on three-way switching, power goes in one side, comes out the other. The two travelers connect these two switches together so that no matter what switch is turned on or off, they both can control the light.
The travelers are connected to the neutral?
No. Three-way switch has 3 screws on it. Switch now. It has a common and 2 travelers. The 2 travelers connect both switches, but on the common, power comes in one common and will go out the other common to the light. Okay. So my power is coming in from here, but the switch wire is going out of this switch to the light. And the neutral is neutral. The neutral doesn't go through your switch. There's no white connected here. There's no white connected to the switch.
Is that a green wire coming out of the back of the new dimmer? Is that an additional wire?
It is.
But you don't use that ground wire
No.
in this?
No, in this case, in Chicago, where everything is metal, okay, that is grounded, it's all, once I screw this switch to the metal, it's automatically grounded.
Yeah.
And you can see that if you look at a normal switch, okay, it has a ground wire screw on it, but it's part of the strap. So once I screw this to the metal box, it's grounded without putting a green wire here. If I'm outside, let's say Cook County, and we've got plastic boxes and plastic piping, that's why the ground wire comes in. Because then you have to have a ground wire because the conduit and the boxes are plastic. It doesn't, will not give you a ground. Same thing with an outlet, got a ground screw, but it's part of the strap. In Chicago, we don't need to use them, okay? Or in Cook County mainly, you don't need to use them. Once you start getting into plastic boxes and Romex and things like that don't have a built-in ground, then you need a ground wire to each device to make it safe. That's all.
It's interesting. Why is Chicago different from other places?
Through a lot of experience, New York and Chicago have the toughest codes in the United States. Obviously, including fire codes, by the way, with well here to the earth, here, fire. Well, a lot of that also exposed electric wiring to problems. Whereas you heard knob and tube wiring, it's actually not bare wires, but cotton coated wires running through the 2x4s. All right, well, what happens in that case, if you have a bad wire, you start a fire. So why metallic tubing, conduit? For that very reason. It provided protection against fires. Okay, if there was a bad wiring, it would hit the ground and blow the fuses. That's why we have metallic wiring. Through a lot of accidents, if you want to put it that way, that's why New York and Chicago have the toughest codes. Of course, we've been around the longest too. We know what worked way back when. Way back when they didn't have plastic piping. The old conduit was basically water piping. Just a slightly different thread, that's all. Any questions?
Can you explain the screws again? You said like 2 brass and black.
On a three-way switch,
Yeah.
there's 3. Here, let me get one and I'll show you.
I need a box of the cover for outlet. Oh, you busy?
Yep.
Yeah. I left. Yeah.
All right, here is a three-way switch as opposed to a standard on-off. Your standard on-off basically has 2 screws on it. We ignore the ground screw. Whereas your three-way switch has 1, 2, 3. All right, notice the dark screw. All right, notice the 2 normal brass screws. All right, ignore the ground here. All right. So, and on the switch itself, it even says common. So if I have 2 switches on it controlling that one light, or motor or whatever, my power comes in on the common, the 2 travelers go to the next switch, and the power, the switch wire, comes out the other common. That's why they color code the screws on a three-way switch.
So the common is the dark one.
Right. Or in this case, on the dimmer, the black wire, as opposed to the 2 red wires.
In this scenario, if the situation is to when one of your outlets goes bad, you check it with the tester and it goes bad, you go inside, you see it's bad, pretty much cracked. Okay, you replace it, but you still have no juice. Do you go to the main source and find out? Or how does that work?
Yeah, normally if you have a cracked outlet, it's probably going to short the ground and shut off your, or blow your fuse or shut off your circuit breaker too.
Right.
And again, but before you start working on it, aren't you going to test the wiring before you even start touching the wiring?
Okay. See where you're headed.
Okay.
I'm learning.
So if you, in fact, if you do have a cracked outlet or a burnt outlet, either one, and you know, first you can test it here. All right. Okay, it still doesn't work. Now I pull it out of the wall or out of the box, as the case may be, and again test it to ground. Make sure that, in fact, it is off while I'm working on it. Well, yeah, if you got a bad outlet and now you have no power to that outlet, you've got 2 problems. 1, no power, and 2, a broken outlet. So first you replace the outlet with a good one, then you go find out why you have no power going to it. Whether it's as simple as turning a breaker on or off, or replacing a fuse, or if that's not the case, then you have to find out where you can probably have a burnt wire somewhere, and you have to go and find that.
I might have missed it, but, you know, in terms of checking power to a switch, not to just a general regular switch, how do you do that to make sure that that you shut off the right circuit?
Sure. Again, any switch is going to have a hot wire on it and a switch wire. Okay, so one of them has to be hot. All right. If I've got this switch, you know, and I want to see which one's hot, just pretend there's wires hooked to this thing. Do one, touch the box, no light. Take the other, touch the box, and it should light. If I don't get a light on either one, that means that it's not the switch that has the problem. There's no power getting to the switch if I don't get a light on one of these. Now, and that's when the switch is off, I'll get, if the switch is then turned on, both of these should test hot. With the switch off, only one is going to test hot. The other is the switch wire. The switch wire is only hot when I turn the switch on. That's the difference.
Okay, but if I have to, and I mean, this is my issue, is I have to switch out a switch because it's just, you know, it's older than God. Okay. That I have to figure out which circuit it's controlling it. That you can flip it and then it should all be cold.
Well, your easier way, if you have that switch, is it still functioning? You just want to change it.
It's acting up, so.
Well, what does it turn on?
So sometimes it's very stiff and I can't get it to stay up.
Okay,
So
well,
that's
again,
what I'm-
turn it on. What? This is for a light?
Yeah, it's for.
All right. The light's on.
Yeah.
Go down to the circuit breaker box, have somebody watch the light, and start flipping circuit breakers. When the light goes out, you know you turn the switch off.
Sometimes it just doesn't hold up there where the light will go on, and so that's what it is.
Mm-hmm.
Sometimes it will, sometimes it won't, and so I'm sitting there saying, oh, do I have to shut off all the switches in order to figure
Well,
out
no,
what it
get it so it stays on, and then go
is,
to.
all that stuff. Yeah.
You don't have to switch it all off. Just find which one it switches off.
Yeah,
All right.
that-
And then you're okay. Any other questions?
You mentioned like a burnt wire. If it's like a bad wire, like you check, like you see that there's no power coming in, hot wires, so you're like, it's probably like a bad wire. Is that time to call an electrician and probably not DIY?
Probably, yeah, because now you have to, and trying to track wire in conduit, none of this will work, by the way. And even with the best equipment that's out there, and I'm talking well over $1,000 worth of equipment, it's guesswork and art. And trying to track wire through grounded conduit is next to impossible, even with the best of equipment. Okay, simply because everything's grounded. All right, you see these guys maybe in the city, they're tracking wires under the sidewalk and whatnot. They have a reference point, which is called ground. All right, where they're tracking a hot circuit. Okay, but in the house, the whole thing is grounded. All right, going underground is a different story because your reference is ground. I don't have a reference because it's buried in the ground. Unfortunately, it's surrounded that way. That's the difference between a piece of equipment designed to find something 6 feet underground, all right, that costs $5,000. All right, you can use that same piece of equipment here, and it wouldn't function very properly because this whole thing is grounded. Okay, and it can't measure the ground and separate the pipe from the ground.
The very last question is related to his question. If it's undergrounding, as you mentioned, but also the wire is going outside and it's really old, is it part of Commonwealth Edison? Is it part of my house?
The pipe and the masthead, okay, and the box and the wiring is yours. The meter belongs to ComEd, okay, and the wiring from where it connects to your wire to the pole is ComEd. Okay, but that wiring coming down the pipe to the meter and then going inside the building is yours. The box that holds the meter is yours. Okay, the pipe and the masthead and all that wiring is yours. The connection, okay, is ComEd. Now, can I, as an electrician, go up there and pull the meter and there's a problem one of those connections got burnt, and can I connect that as an electrician? Yes, I can. Okay, I can pull that meter out, shutting off the power. All right, that just shuts the power off going inside. That's still hot up there. That's coming from the pole, okay? So you have to be extremely careful when you're working up on that.
A lot of voltage.
Yeah, right.
Last but not least, I just want to thank you. This is a very intense class. I hope you repeat it again.
No, thank you.
Thank you.